Systemd is a comprehensive software suite utilized for system and service management in Linux environments. It aims to standardize service configuration and behavior across various Linux distributions. The primary component of Systemd is an init system responsible for initializing user space and overseeing user processes. Additionally, it offers substitutes for multiple daemons and utilities, such as device management, login management, network connection management, and event logging. The naming convention of system follows the tradition in Unix systems, where daemons have a D appended to their names. The name system is also a clever play on the French term systemd, representing an individual's ability to adapt and improvise effectively when faced with challenges. Since 2015, Systemd has been widely embraced by almost all Linux distributions. Users and developers of distributions that have incorporated Systemd have lauded its stability and quick functionality in addressing long-standing issues within the Linux ecosystem. Notably, Systemd was the pioneering parallel boot and init system that centralized the management of processes, daemons, services, and mount points. Nonetheless, critics argue that Systemd has expanded excessively in terms of features, leading to potential interoperability issues across Unix-like operating systems, as it is not compatible with non-Linux Unix variants like BSD or Solaris. Moreover, the extensive feature set of Systemd is seen as increasing the system's vulnerability to cyber attacks. Consequently, a few minor Linux distributions have emerged, opting to replace Systemd with alternative init systems like sysvinit or OpenRC. Lennart Poettering and Kees Sievers, former Red Hat software engineers, initiated the development of Systemd in 2010 as a replacement for Linux's traditional systemd init. Poettering's blog post in April 2010, Rethinking PID1, unveiled the experimental version of what eventually evolved into systemd. They aim to enhance the software framework for articulating dependencies, enabling more concurrent processes during system boot-up, and reducing the computational burden of the shell. By May 2011, Fedora Linux became the pioneering major distribution to adopt Systemd by default, supplanting Upstart. The rationale behind this transition was Systemd's capacity for extensive parallelization during system startup, superior process management, and a more rational dependency-oriented system control approach. Arch Linux followed suit in October 2012, abandoning sysvinit for Systemd, after deliberations that underscored Systemd's speed, richer feature set, and the diminishing value of sysvinit maintenance efforts. Critiques against systemd, such as its utilization of dbus, preference for C over bash, and the optional on-disk journal format, were paradoxically viewed as strengths by Arch maintainers. Subsequently, a contentious discourse unfolded within the Debian Technical Committee from 2013 to 2014 over the default init system for Debian 8, ultimately culminating in the selection of Systemd. This decision prompted resignations from key figures within the Debian community due to the strain caused by the system integration disputes. Mark Shuttleworth subsequently revealed that Ubuntu, a Debian-based system, would also adopt Systemd, replacing its existing Upstart init mechanism. In August 2015, Systemd introduced a login shell accessible via machinetl shell, expanding its functionalities. However, in September 2016, a security vulnerability surfaced, allowing unauthorized users to launch denial-of-service attacks against systemd. Rich Felker, creator of Moosel, highlighted this flaw as a fundamental system development design flaw. The security issues persisted in 2017 with the discovery of another vulnerability in Systemd Resolved, known as CVE 2017-94R45, which could be exploited by a malevolent DNS server to disrupt services. Lennart Poettering faced criticism in 2017, receiving the lamest vendor response award at the Punny Awards due to his management of these vulnerabilities. Poettering characterizes the ongoing development of Systemd as a perpetual journey, always evolving alongside technological advancements. In May 2014, Poettering highlighted Systemd's role in bridging the gap between various Linux distributions by offering a trifecta of roles: a comprehensive system and service manager that governs system configurations and services, a foundational software platform for developing other applications, and a vital intermediary connecting applications with the Linux kernel by exposing kernel functionalities through various interfaces. Systemd boasts a range of features including on-demand activation of daemons, snapshot functionality, process monitoring, and inhibitor locks. Beyond serving as merely an init daemon, Systemd encompasses an entire software suite, comprising essential daemons like journaled, login, and networked, in addition to numerous low-level components. Poetering in January 2013 shed light on system's expansive nature, portraying it not as a singular program, but as a vast collection of 69 individual binaries, each serving a specific function within the larger suite. Functioning as an integrated software suite, Systemed revolutionizes traditional startup sequences and run levels managed by the conventional init daemon, supplanting shell scripts executed under its aegis. Moreover, Systemed encapsulates a host of services essential for Linux systems, encompassing user logins, system console management, device hot plugging, scheduled tasks, replacing cron jobs, system logging, hostname, and locale handling. Acting as a daemon overseeing other daemons, System spearheads the booting process as the initial daemon to start and the ultimate one to cease action during system shutdowns. With a unique approach to startup sequences, Systemed executes components in parallel, potentially accelerating system boot up compared to conventional methods. For inter-process communication, Systemed leverages Unix domain sockets and dbus, offering robust support for running daemons. By utilizing the Linux kernel's cgroup subsystem instead of process identifiers, Systemed ensures daemons remain under its purview, preventing any escapes even via double forking. Systemed extends its functionality through systemd nspawn and machinectl, facilitating the management and creation of Linux containers. Furthermore, since version 2.05, Systemed has incorporated control group interface, providing an interface to Linux kernel cgroups, which are being refined to accommodate a unified hierarchy. In addition to its foundation as a Linux init system, Systemed includes ancillary components to enhance system functionality. These components span a variety of services such as System journaled for event logging, libudev for udev resource querying, localed for system locale management, logined for user login and seat management, and networked for network interface configuration, which saw significant enhancements like the integration of a DHCP server and VXLAN support in version 215 of Systemd released in July 2014. Systemed's extensive toolkit also includes utilities like Systemd boot for boot management, Systemd nspawn for namespace container operation, Systemd time-dated for time-related settings control, time-synced for network clock synchronization, and Systemd tmp files for temporary file management. Additionally, Systemed offers a plethora of core components and libraries like systemctl for managing system states and Systemed analyze for boot-up performance analysis, underscoring its comprehensive approach towards system management and service control. Various Linux distributions have different stances on supporting System as the default init system. Arch Linux officially only supports System, although it provides instructions for using other init systems. Debian's Jessie release was the last to allow installation without System, while some alternative init systems are supported in the Bullseye release. The GNOME project considered making System an external dependency but decided against it, leading to GNOME becoming dependent on Systemed for many Linux distributions. The design of Systemed has sparked controversy for being overly complex, deviating from the Unix philosophy, and creating interlocked dependencies. Critics have likened the situation to Pulse Audio. Despite reservations from some, Debian opted to retain Systemed as the default init system, with room for exploring alternatives. This has led to debates within the free software community about the impact and implications of Systemed on the Linux ecosystem. Forks of Systemed have emerged as responses to critiques outlined in the previous section, with the aim of enhancing aspects such as portability to other libcs and Unix-like systems, modularity, or size. One notable collaboration among some forks is the Free Init initiative. For example, the Gentoo Linux project introduced udev in 2012 as a fork of udev to break away from reliance on the Systemed framework, enabling udev functionality independent of Systemed. Despite Gentoo discontinuing support for udev in 2022, a group of independent maintainers has since taken up the project. Separately, Elegend evolved from the System project's login to function as a separate daemon, assisting in identifying logged-in users and their status within the system. This information can be accessed through dbus and the file system, providing functionalities akin to those in libsystemed. ConsoleKit 2 emerged as a fork of ConsoleKit by XFCE developers in 2014 to maintain its features beyond Linux, with considerations for future developments until SystemBSD matures. Conversely, abandoned endeavors like LoginKit aim to serve as a systemed login shim to eliminate init system dependencies, but the project ceased in 2015. Additionally, SystemBSD sought to offer alternate implementations of specific APIs for OpenBSD without introducing new system-like elements, emphasizing compatibility with OpenBSD's existing components. This project aimed to be installable as part of the ports collection. Not System was formulated to integrate all features of System across various init systems, developed by Parabola GNU Chuck Linux Libre to operate without a mandatory system installation. Another endeavor, Uselist, emerged as a lightweight systemed fork in 2014, stripping away perceived unnecessary features for an init system, catering to Musl and mclibc libraries for potential use in embedded systems. Initware represented a modular adaptation of Systemed, transferring its functionalities to BSD platforms without glibc or Linux-specific calls, extending compatibility to Dragonfly BSD, FreeBSD, NetBSD, and GNU Chuck Linux, while shedding redundant components. The annual Systemed conference, All Systems Go, takes place in Berlin. While Systemed serves as the main focus of the event, various other Linux-related topics like TPM, dbus, desktop environment, containers, and eBPF are also explored throughout the conference.